Yeah, you're welcome back to a session with Educator Mathematics with your own boy. Um, Please endeavor to keep subscribing to this channel and sharing with students and for as many who will need to watch this video. Make your likes, your comments, and every observation known. Today, we are on statistical graphs. So we did something on using of histogram to solve or to find your median and the mode without calculations, just on the graph. So quickly, we're talking about the cumulative frequency curve, which is also called ogive. But before that, let me mention frequency uh, distribution. I mean the frequency polygon. It's just a slight difference from the histogram distribution that we did in the previous video. After drawing your histogram, all you have to do is make sure you get the midpoint of each of those bars, get them, link them together. Then that's all for the frequency polygon. Then quickly, let me get back to cumulative frequency, also known as ogive. There are certain terms you should know when dealing with this, and some of the things I've mentioned here. The median is just to, if you are looking for the median with the use of your cumulative frequency curve, what you need is the 50th percentile. Now let's talk about the percentile. Percentile means 100 divisions. So I can tell you, okay, find first percentile. First percentile just means 1 over 100 times the cumulative frequency. Second percentile, 10th percentile, that is 10 over 100 times the cumulative frequency. If you've been taught how to get the cumulative frequency, sure. Then that's for percentile. Let's talk about deciles. Deciles means 10 divisions. So if you are looking for second decile, that is 2 over 10 times the cumulative frequency. That will give you your second decile. Fifth decile, about 5 over 10 times your cumulative frequency. Then we'll go for quartiles. Quartiles, you can see here, quartiles are in 4 divisions. So you have your Q1, 1 over 4 of the cumulative frequency, then Q2, 2 over 4 of the cumulative frequency, Q3, 3 over 4 of the cumulative frequency, and each of these represent or means something. Q1, it is known as the lower quartile, 1 over 4 of the cumulative frequency. Everything is times the cumulative frequency. Then Q2, known as the middle quartile, 2 over 4 times the cumulative frequency. Upper quartile is your Q3. It is 3 over 4 times the cumulative frequency. And interquartile range. Please, you can be noting these things down. I don't have to write everything. So, and your interquartile range, it is Q3 minus Q1. So if you have Q3 minus Q1, that is your interquartile range. Then your semi-interquartile, that will just be your Q3 minus your Q1, then you divide it by 2. That is what we call the semi-interquartile range. And that's all. So quickly, let's attempt the question that we have before us. With the knowledge of what we have done, and please, when you are working with a cumulative frequency curve, you need 2 things. The cumulative, just from the name cumulative frequency curve, you need the cumulative frequency, and then you need the upper class boundary. That's all. You need the upper class boundary. So with that, you are good to go and you can solve any question relating to this concept. So quickly, we have the question. It says below is a cumulative frequency table of the lifespan of 100 miles in a farm. 1 or A, draw the cumulative frequency curve of the distribution. 2, estimate the semi-interquartile range. 3, okay, CII. BII, estimate the number of mice still alive after 120 days. So, oh good, we don't need this. Let me clear this off. We don't need this. We don't need this. Okay, but I need to make an illustration with it. So don't forget, I mentioned in the previous video how you estimate your class boundary. So now, from the information we are given here, we have lifespan in days, you have cumulative number of mice that represents the cumulative frequency, then the lifespan in days that will go for our what do you call it, the class boundary, which we are not given exactly, as in we don't have something like this. So as when we have something like this, we pick these upper class boundaries to plot against. So we plot the cumulative frequency against the upper class boundaries. But this the lifespan of the lifespan in days has been given at the upper class boundaries. So get it. It's possible you are given a question, you have given a question, it involves class marks, you have to deduce your class boundary. You will not use it 0 to 95 just like we did when we were constructing our histogram. You will use the upper class boundaries alone in place of all these numbers here. So which means I want to believe you now understand what I mean by that. So I don't need this. So we go to this. Now how can I represent this on my graph? Okay, I have 22, I have 5, 20 to 5, I have 50 to 20, 40 to 75. So knowing fully well that my cumulative frequency will be on the y-axis. Oh, so 22, 25. Okay, let me have an interval of 25, 25. I have an interval of 25, 25 here. So permit me. Okay, for the cumulative frequency, our cumulative number of miles 520. Okay, I think I can use 20, 40, 60, 80, then say 100. Yeah, because I don't have enough space. So let's do it that way. Let's do it that way. So we have this. Yeah, I think we're good to go. So we have 20, 40, 60, 80. Okay, good. So we can move. We have here. Now, for my lifespan, 22, I'm going to 150. And I need an interval of 25, 25. So let me see how many boxes I can represent with. We have 150 by 25. Okay, 6. So let's say 6 times 4, 24. I will take each of these boxes to be 5 centimeter, 10, 15, 20. So 20 centimeter will represent 25 units. Yes, on my x-axis, 20 centimeter represents 25 units. So let's go. 1, 2, 3, 4, 5, and 6. So I have that. So I think this time I will want to go this way. 1 2 3 1 2 3 4. I have this 24, so I'll pick this to be 25. From here again, 1 2 3 4, pick this to be 50. 1 2 3 4, take this, you have 75. 1 2 3 4, take this, 75 plus 90 plus 15, this is 90. Yes, the 90, 1 2 3 4, 90 plus 25, 90 plus 25, 115, 90 plus 50, 115 plus 25, I have 140, so I have one more to go, 2 3 4. So 140 plus 25, I have 165. If I have 165 here, good. Now, from my y-axis, I don't forget, the cumulative frequency is the cumulative frequency. I'm plotting it against the upper class boundaries. But here we don't have to deal with upper class boundaries directly, because the lifespan is taking care of the upper class boundaries. Please take note. Then we move. For this, I pick this to be 20. So I have 20. This is 20. And this is 40. This is 60. This is 80. So I have 100. 20, 40, 60, 80, 100. So I can pick my points from here. Now, the first question is draw the cumulative frequency curve distribution. So let's go with 5 to 25. If this is 20, this will be 10. And if this is 10, I want to pick this. This should be 5. Yes. So the y-axis starts from 5. This one starts from 0. The x-axis starts from 0. So I pick this as 5. 5 to 22. So this is 25. 1, 2, 3, 4. Divided by, okay, let me say my 20 is around this region. Picking this to region, yeah, it's 20. 20 to 22, sorry, 22 to 5. Then the next one, 50 to 20. 50 as a lifespan, this is 50. Then to 20. Okay, there's an error here. this should be wrong. Let's be very careful. 22 as a lifespan. This is where is the lifespan? Okay, this is lifespan. Then 5 as the cumulative frequency. Okay, it will fall here, it will fall here. Yeah, it will fall here, it will fall here. So I think that is still correct. To fall here. Then lifespan here is 50. This is 50. Then we have this to 20. 50 to 20 cumulative frequency. Then 75 to 40. So I have 75 to 40. This 75 to 40. Okay, no, it shouldn't be a double line, just a single line. Right to 40. I have 100 to 60. So who is 115? Let me pick this as 100. 100 to 60. So please, you must have an accurate. You must have an accurate way of calculating the points, each of the points between each the successive values you have here, either on the x-axis or on the y-axis. You must have an exact way of doing that. So you have 10 to 60, 125 to 80, 125. So I have 125 here to 80. This is 80. So I have 125 to 80. Then 150, 152, 152, 90, 150 to 90. So this is somewhere here. No, that is 100. So that is wrong. The 152. 150 to 90. Yeah. So I haven't gotten that. You trace them, trace them, trace them, trace them, trace them, trace them. So all you have to do is trace this, trace this, trace this to get your OGIF. Trace this to this, trace this to this, trace this to this, trace this to this, trace this to this. So that will form your OGIF. Now, the next question is estimate the semi-interquartile. Don't forget I mentioned that the semi-interquartile, let me write it as S interquartile IQ. Interquartile range, semi-interquartile range is Q1 or Q3 rather, we've got look for Q3 minus Q1 upon 2. And that will be what? What's our Q1 and Q3? Q3 should be 3 over 4 of 100. So we have 3 over 4. Let me see. 3 over 4 times 100. That should be equal to 75%. That's Q3. Then Q1. Q1 is 1 over 4 of 100. 1 over 4 of 100. And that is equal to 25. and 5%. So now at the graph, since we have Q3 to be what? Q3 is 75%. Trace 75% from here, trace it to, let's say it's 75. Let's trace it to any part of our ogive. So we go this way. 1, 2, tracing, 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 tracing. Yeah, got it. Yeah, 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 yeah. So we get the value there. This is our Q3. This line. Then what do we have there? I think there we should have 120. Yes, should have 120. This is 120. So what do we have now? Then we go to 120 minus, go to 25%. 25%. 25% is here. To do that properly in your book, we get the exact answer. So this is Q1. So 25%, that will fall at 55. So I have Q1 to be 55 divided by 2, and that will give us 120 minus 55. That gives us 65. Then mine divided by 2, I have 32.5. So my semi-interquartile range is 32.5. This, let me note this. 32.5, and that is equal to, okay, I have 32.5. That's my semi-interquartile range. Then the next question, of course, it should be in number of days. So you have 32.5 days. Then the next question is estimate the number of mice still alive after 120 days. Okay. Where's our 120? Oh, good. So good. So good. So the 120, we go to the 120 days stand for the cumulative, the upper class boundary, right? So come here, locate the point for 120, and okay, coincidentally it was what we have done before. So we trace this back. I'm using this red now. This. Then you move this way, 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 and that we are able to locate 75%. Able to locate 75%. So 120 days, it will be 75%. Yes, that will be for 75%. They said what, estimate the semi-interquartile range. Okay, no, that is done. Estimate the number of mice still alive for 120 days. So don't forget, this place is your cumulative frequency. So there we indicated 75. It's not percentage, don't mind me. It is 75. But now, because when you are calculating your cumulative frequency, look at this. Good, thank God I've not cleaned this off. The cumulative frequency for the second class interval is 10. But how do we know the number of the frequency for that class? is to subtract from the what? The preceding class. So which means you remove 3 from 10, you have 7, and that will be the class frequency, the frequency for this class. The same thing we will do here. This is already 70. Abi? So we remove this 70 from 80. What will be that? So we are supposed to have 80 minus 70, that is 10. So for those mice that will be alive for 120 days, we have 10 miles. Let me indicate this. The BII. This one is for I. So we have 10 miles. Alive. I don't even need to write these stories. Just know that it is 10 miles. So thank you very much for watching. Okay, we've exhausted the question. Thank you. Please don't forget, keep subscribing, share. See you some other time.